and then we can go back there. Right. Okay. So we're going through the problem, and okay. So 5, 4, 11, 7, 2, 8, 13, 4, 5, 1. So like as I was saying earlier, I think the way to do this would be like depth first search, right? So you'll just keep going down until you reach your base case where um, if left equal null and right, okay? So you're at that case. And as you go down a level, you push onto your stack. So in this case, our stack would look like something like, I guess my thinking, and hopefully this gets up ends up being right. So our stack would be 5, 4, 11, 7. So we get here, and then we're basically like, oh, okay. We could end it earlier too, by the way. But like, if you're past that point, but like, let's not. Like, let's keep it simple, base case type of scenario. Um, right. So essentially, um, I'm gonna see if I can see the screen and do it, but like I can't. There is way too much lag. Is this stopped? Making sure it's shared. Okay, yeah, looks good. So I think you just stopped sharing there for a second. Anyways, so basically when you reach this, check the stack, so compute target. So, and in this case, I can make use of like a actual stack, or I can just use like a vector. That's probably what I would use. Compute target, and then equal target, dump to result, dump to res. And then when you go up a level, um, you want to remove from the stack, and then go down a level, add to stack. Okay, so like I kind of know where this is going, and this is the part that like I find really hard. Um, at what point do I do that? I don't know. What happens if I turn it off? Okay, so we'll just turn that off. Put my iPad away, and then let's switch over. So a few things. Uh, we have like a outside, and we'll call it vector. So we'll have like something like that. And then I usually like to call like a recursive function like that. I just make it. And then this function would be like a void. So I can call this recursively. And so this is usually how I handle my recursive functions. And then like I'll just see if this is like needed or not. So okay, so tree node. I just called in the node, and then we'll call it Okay, then we'll just sec if node null pointer and okay, so check if we meet target. I'm just gonna use a vector for now. And we'll check that. So then we'll just say for auto, um, right. And then we'll just do for const. Actually, we don't need to do anything here. For const auto num in stack. Right. So if sum equal target sum, then we'll just do res dot in place back, and then we'll just give it like the stack. So like it just pushes like the one that we've been basically building up. And then once you're done this, just return. Like so you're at the leaf node. So why not just return? And then here, we're just gonna do that. Okay, else you are not the leaf node. So then let's like push back what we have, stack dot push. We'll then place back our node val like that. So we are on the stack. Uh, and then if node left pointer does not equal null pointer, yeah, if node left pointer does not equal a null pointer, we'll just call pad sum r, and then we'll call it with node left pointer. And then like when you come out of this function, let's make sure that we pop. No, we don't want to pop. Uh, sorry, I didn't mean to do that. I think we need to do this right here. So you always pop your value. Sorry, place your value on the stack. And then when you go to the left pointer, you'll be here and then you'll return. And then, so because you're returning, you want to do, no, let's keep working on this function. Uh, that was kind of scary. uh, pop, oops, poop, like pop the back. And then, yeah, so like that. Okay, so I think this should work. And technically we didn't need target sum there. You could see that we could use like a private variable. And I might want to do that, but like, I want to make sure this like makes sense. So we'll call this with our root node and our target sum, and then we'll just return the res that gets built up. And then for void path sum r, this will be like our public recursive call. And like technically this should be a private function. So that's how I would write it. So, okay, so the first thing you call it, you put your value onto it, so that the root node will put 5 on here, and then it'll check if if you are like leaf node, and we can check that pretty easily because like if it has no left or right, you're the leaf node, right? Like if this has no left or right, that always has a left, it's not a leaf node. So when that happens, you just compute all your value on your stack, which you put yourself on there as well on earlier ones, and you just sum, and then if the sum is equal to target sum, you replace back the whole stack. And then if you are not the leaf node, then if you do have like a left pointer, then you'll go down that route, and then when you come back from that left route, you want to make sure that you pop that value out, and then you go down the right value, and then you want to make sure that you pop that value out as well. Um, yeah, I think that should be it. I'm just thinking if you have another case uh, that you might want to pop, but I don't think so. Uh, okay. I was like, what's going on there? But they don't call it pointer, they just call it left, right? Uh, what am I doing wrong now? Oh yeah, the sum target. Let's just take that out. And then so many issues just running your code. It's so embarrassing. Yeah, it was like, oh, if I got this on the first try, that would have been sick. But no, I didn't. Uh, oh, what happens if there's none? Yeah, sorry, I didn't check. Empty. La, la, la. You gotta check for those cases. Like it tells you, like always check for those. I don't know why I don't. Hey, that's not even bad. Um, I think this was a pretty decent solution. Okay, so I like to mark this on my documents. This is a no, this is a tree question, and this was path sum two went well. I'm really curious how others implement this. So path sum, answer, temp, solve, and then if null pointer return, otherwise push back. They do it the exact same way. I'm just curious how theirs is faster. If target equal root val and what? If target equal. Oh, because you subtract from the target, I guess, every time. Oh, okay. Yeah. So the way they do it is that they remove that duplicate call. Um, that's a minor thing. I wonder if I would have figured that out, but like you don't have to do this. As you go down, you can see if you're gonna reach the sum or if you're not, and do it that way. I think this is good enough to showcase that I could have done the problem. Like I don't know how much more people would want, But yeah, I want to see how long that took. So let's just go to the other benefit of doing this. We're 16 minutes back. Those dots doesn't look as good. This is like 5. Where yeah, I was at the 15 minutes. Case, but like I am pretty proud of that one. That's cool. Like yeah, you could have done the optimal one. Yeah, I mean whatever. Ah shit, this is just seems annoying. Right, number of edges is just -1. 1, 2, 3, 4. 1, 2, 3, 4, 5. Yeah, this one seems annoying. So you go down and then you find your number. So in this case, like let's say it's 4, and you go down left contains 4, and